Right, year nines. I thought we'd do a second lesson, I believe like Mr. Mackenzie's group did, on changing the subjects. And we're going to look at some that were possibly a bit more complicated than yesterday, or you might think we're doing exactly the same thing, but difficulty hasn't changed. Just to remind you, the idea is that maybe with an equation like y equals 3x plus 2, where y is the subject, we can rearrange that to make x the subject. So I can move the 2, I can move the 3, I can end up with x is y minus 2 over 3, where x is the subject, x is expressed in terms of y. This formula and this formula are identical, they're just rearranged. That's the idea, rearranging things. We can make it more complicated. We can make it more complicated by starting with more complicated formulae. Let's say I started with v equals pi r squared h. So v is expressed in terms of pi, a number, r squared and h. Well, notice two variables, 3. I could rearrange this in a couple of ways. I could, for instance, I could divide by the pi, and I could then divide by r squared. That would be making h the subject. I could instead start with the same thing, and I could divide by pi. I could divide by h. Then I could find a square root. But remember, if r squared is this, when I put the root sign in, I'd have to put plus or minus that. R could be plus or minus that. Now, context might tell us if r has to be actually a radius, because the context, perhaps the negative isn't appropriate. But in the abstract it is. So here, same formulae to start with, could be rearranged to make r the subject. It's all about reversing what the letter or number you're moving, what process it's, what it's doing to the side it's moving from, isn't it? The pi was multiplying there, it divides on that side. The pi was multiplying this side, it divides on that side. So, Mr. Mackenzie's class went on from the first lesson to do a few more complicated ones. Let's pick a couple as examples. So these are the sheet you're going to look at. They're going to be very similar. So I'm going to write that y is a b plus 2x. Can we make x the subject here? It's about working your way to the x, isn't it? I could divide by the a, and that would leave b plus 2x. Right, so that's x doubled, then with b added. So the reverse of that in the reverse order. Take the b. Then I could divide by the 2. How could I write that? Well, that's not overcomplicated. Why not just write that halved? Would be absolutely fine there. Now, if you wanted to show off, and say that's the same as a denominator of 2a and y, put b over denominator of a. If you wanted to write that, fine, but they're equivalent. Either is good. So it might be the case when you try some of these ones that Mr. Mackenzie wants you to do. So Mr. Mackenzie's given to me for us to do. If you don't quite get the answer, it might be you've got an equivalent answer. It just looks different. Right, let's try a couple more complicated ones. This is just getting to the swing of it. And then have a look at the questions I've sent on the separate sheets. I'm just looking at some other examples of one. Oh, that looks a good style of question. What about one that starts off with y equals z take 3 lots of root x over 5. And let's say I want x to be the subject. Now that looks hideous, doesn't it? Just do it step by step. If you're going to eat an elephant, do it one bite at a time, okay? One bite at a time. So, how could I make x subject? I don't like the minus sign there. That annoys me a little bit. I'm going to put that term onto this side. So I'm going to call it 3 root x over 5 plus y is z. Then to get to the x, I'm first of all going to move the y. So z take y 3 root x over 5. The 3 is multiplying that, the 5 is dividing that. I can actually do these steps in either order or even at the same time. What do I mean by that? I can multiply by the 5. I could multiply that out, I just don't need to. I could then divide by the 3. I could have done that, divide by 3, then multiply by 5 and get the answer. How do I get rid of square rooting? I square everything. So I can square the 5, I can square the 3, and then very lazily I can say that that is squared. So even though it looks complicated, it's just about moving. I put that to the other side to make it positive. Then I've got to work my way through the y, the 3 and the 5. Okay. I'm just looking at some of the other crazy shaped ones he's got here. So they all seem to be making, in the second exercise, it's all making x the subject. But I've got another good one. S equals ut plus half at squared is a nice formula from the A-level work. It's actually to do with displacement and velocities and time. Let's say, for argument's sake, I wanted u to be the subject. Though it looks complicated, this term here, which doesn't contain u, can just be moved in one go. And then I can simply divide by the t. So I could write s divided by t, take half a, and if I divide this by t, I get t. That would be fine as an answer. U is s over t, take half a t. What about if I wanted a to be the subject? Again, let's just move that term in its entirety. That term is halved at the moment, so I could double both sides. Don't forget that this term is a times t squared. The a is not being squared, so I'm just going to divide by the t squared. How could I write that? Simply write it as over t squared. Do I need to simplify it? No, not at our level. Okay, now I'm just having a look on my screen to see, are there any other crazy shaped ones? I'll tell you what, there are some crazy shaped ones. He's even put a little skull and crossbones by some really wickedly difficult ones. Why not have a crack at, there's 4 sections, do whichever ones you like, pick your challenge, and if there's one really challenging you tried and you couldn't get it to work, email me with the question number, and then I'll produce a short video if we think these are useful to go through them. Okay then, so you'll have found this because I'll have sent an email with the link. Attached to the same thing should be a document. Follow the instructions. Good luck.